Alrighty, so another way to add vectors together is what we call the parallelogram rule. So if you take your initial vectors and you put their initial points together, and then what you're going to do is you are going to come up here and you are going to parallel vector A. So this is also the length of vector A. And you're going to go to the nose of vector A and you're going to come straight up and you are going to make a parallel and equal vector to B. Then what you're going to do is you are going to connect the opposite corners where the two initial points are. You're going to go out to the opposite corner, and that would be the length of AB. All right. So fun fact about parallelograms, and we're going to need this in a little bit, so I wanted to address it here. This angle up here in the corner and this angle are always going to be the same. And then these two angles, this angle and this angle, are always the same. Notice the resultant vector doesn't cut it in half. And what you also need to know is that the blue angle plus the green angle is going to add up to 180 degrees. So we're going to use that and law of sines and cosines to find some vector lengths. Okay? So let's take C plus G and use the parallelogram method to find the resultant. Now it's going to be the same as the last C plus G, but let's see how this one works. So I'm going to start with C, and here is vector C, and I'm going to sketch G coming off the initial point of C. Boom. So there is G. Now what I'm going to come across from G, and here is a side that is going to be equal to C, and then I'm going to do the same thing right here, and this length is equal to G. My vector that is going to be the answer of the two, start at the initial point where the two vectors touch, come out to the opposite corner, and this vector is C plus G. Easy peasy. Now, another fun thing we can do with vectors is called a scalar. Oh, I'm sorry, I skipped one ahead. So every vector, remember, has an opposite vector. If you add opposite vectors together, you're going to get a zero vector. And so it is a vector literally with a magnitude of 0. It has no force applied to it. No weight, no speed, none of that stuff. Now, what if we actually want to subtract our vectors? So if you start with G, let's start with vector G. I am going to use the tail to nose method. So here's vector G. To subtract vectors, we're going to add an opposite vector. So what that means is I need to add negative C. So this would be negative C. So we're going to start where we left off with G. There's my negative C. And then my resulting vector is this vector right there. So this is G minus C. Notice it matters which vector we are subtracting because that's the vector we're going to find the opposite vector from. So G minus C is not the same as C minus G. Vectors can have a scalar. A scalar is we're going to multiply the magnitude of a vector by a factor, by a number. Like here we start off with vector U. 2U is this blue vector. It is twice as long as the black vector. 3/2 U is this red vector is 1.5 times the length of the black vector. We can go half. We can cut it in half. And then a negative vector would change the vector's direction. Already a negative scalar is going to change the direction. So those are some fun things that we can do with vectors. Just some quick adding, subtracting and talking about scalars. Alrighty, so when we come back, we're actually going to do some vector problems. We'll probably do example 5 and 6 in the next video. So I look forward to seeing you then.